Hello everyone, my name is Bolin. I am a lecturer in College of Civil Engineering and Architecture, Wenzhou University, and a PhD candidate in Welsh School of Architecture, Cardiff University. In this presentation, I will briefly introduce my research of urban space synthesis based on wave function collapse and convolutional neural networks. This presentation is structured as follows. At first, I will start with the introduction of urban space synthesis and explain my research aim. Then, I will explain my research methods. After that, I will explain the general framework. Then, I will present the case study of north extension of central green axis in Wenzhou. I conclude the paper with description of limitations of the approach, its promise, and my plans for future work. The research aim is to develop an AI-aided urban space synthesis approach for fast prototyping of urban design. Urban space is a complicated system. Urban designers need to consider multiple aspects and work with various clients with conflicting interests and aims. Instead of one single solution, varied solutions have to be developed. The urban design process requires a lot of time and labor. Most current urban generative designs are based on procedural modeling, which are the manually set design grammars or rules to generate design. With the development of AI, deep learning techniques are applied in many fields. This research puts forward an approach based on example and learning. This research uses method of wave function collapse algorithm and convolutional neural network. Wave function collapse algorithm is based on Markov random fields. It is widely used in the field of game and AI, and it can randomly generate maps according to custom rules. Similar images can be generated based on the input image by this algorithm. Convolutional neural network is a well-known deep learning technique in recent years. It is widely applied in the field of image recognition, image classification, image generation, and image style transfer. The framework begins with the establishment of urban design database. The second step is urban space synthesis by wave function collapse and convolutional neural networks, and scheme evaluation and selection. The last step is generation of 3D models. Now I will explain a case study of north extension of central green axis in Wenzhou to show the feasibility of this approach. Firstly, according to the design vision and context, 6 cases are selected in the database. They are in Washington, Hangzhou, Wenzhou, Venice, Barcelona, and Paris. Then, the urban street network in the database is extracted as data source for synthesis of urban street network by wave function collapse. And the generated urban street networks are evaluated by researchers to select the optimal option. The evaluation indicators of urban street network include the density of the street network, the accessibility of street network, and the integration degree of context. After that, urban block spatial forms and urban street networks from database are used as paired training examples. Convolutional neural network is used to generate squares and buildings with different heights. The generated urban block spatial forms are evaluated, and the optimal option is selected. The evaluation indicators of urban block spatial form includes the rationality of urban landmark distribution, aesthetic quality of urban skyline, construction land rate, adaptability to topography, raining rate, rationality of urban square, variety of building form, and variety of public spatial form. Then, urban block spatial forms and urban building function layouts from database are used as paired training examples. The building function layouts are generated for the produced urban spatial form in previous step. The generated urban building function layouts are evaluated and the optimal option is selected. The evaluation indicators of urban building function layout includes the diversity of urban building function and the rationality of urban building function layout. The last step is the generation of 3D model. The different colors in the generated 2D urban spatial block form represent squares, greenlands, and buildings with different heights. The algorithm is written by the software of processing. It moves the pixels in the generated 2D urban block spatial form to different heights according to their colors, contributing to a 3D voxel model. And the 3D coordinate data of each voxels are exported. Then the data are imported into the software of Rhino and Grasshopper. And the 3D voxel model is changed to the 3D block model, which is the final 3D urban design model. Now, I will present the limitation and conclusion of this research. There are 4 limitations in this research. Firstly, the image schemes generated by this approach are not very clear. Secondly, the process of scheme evaluation and selection is still subjective and empirical. Thirdly, the format of the data in the database and the generated results are all pixels without topologic features. There is still a certain gap from the actual application of engineering project. Fourthly, this approach is intended to be used for new spaces and cannot be used for the management of the existing urban areas, which is highly demanded in urban regeneration. For the conclusion, I aim to investigate the feasibility of wave function collapse and convolutional neural network for urban space synthesis. Firstly, an urban design database is established as a data source for generation. Then, the street networks, urban block spatial forms, and urban building function layout are generated by wave function collapse and convolutional neural network, and they are evaluated by researcher afterwards. Finally, the 3D models are generated. My research demonstrates the feasibility of wave function collapse and the convolutional neural network for faster prototyping of urban design. For the future work, I plan to use generative adversarial network for generation of urban form. The data of evaluation by researcher will be used for the training by artificial neural network, contributing to an automatic evaluation of generated urban form. Optimization code such as genetic algorithm will be used for selection. I will also investigate a new algorithm which can directly generate design output in the format of vector with topologic feature. This is the end of my presentation. Thank you for your listening.